Hello everyone. The subject of today's lesson is relay. Working principles, representation in circuit diagrams and connection in an electrical circuit diagram. We will answer these questions together in this lesson. Purpose of use in electrical systems. There are many types of relays. Let's give an example of them. If necessary, thermal relay, motor, protection relay, time relay, and magnetic relay, and many more like this. There are also varieties available, but if a general definition is needed according to the purpose of use in electrical systems, we can call it a switching and protective component that controls the load in a circuit. We use these relays to monitor and protect. Friends, the working principles is more like a switching element. We will explain it through magnetic relay, because it is used. Friends, yes, if you want, via magnetic relay. Let's examine the working principles together. Yes, the relay works. If you want to examine the principle, firstly, the internal structure of the relay. Let's examine it together. First, we need to control our relay. There is a coil that we use to make. There is a relay coil for control in the internal structure of the relay. Its label value is shown on the relay like this. It says 24 volts, DC. The supply voltage of this relay of ours is 24 volts, DC, friends. Then, the label value of the load we want to control is also on our relay. It is shown in this figure. We can control an AC load up to 6 amps 250 volts with this relay. Yes, we can. Our relay. The connection legs are named A1 and A2. Thus, the relay. We can see A1 and A2 pins on it. These A1 and A2 are our relay coil. The pins of our friends and our relay coil are this. We can symbolize it in our relay as follows. We have a conductive wire wrapped around an iron core. This coil is already here. It forms the working principles, my friends. Here is the main working principles. The current passing through a wire creates a magnetic field. With this magnetic field, we control our contacts, and therefore, we control our load. We are becoming friends. Yes, our relay. The representation in circuit diagrams of the coil in a circuit symbol is as follows. Friends. You see, as such, A1 and A2 pins are placed in the circuit symbol like this. Yes. We have a symbol to tie our burden later on. Friends, we have one open and one closed contact here. We need our relay. When we give the power, our open contact is closed. The closed contact is open. It has become the working principles works like this one. We have a common end called COM, which is open and closed. The common end of the contact is the COM end. Friends, we provide the supply voltage from here. Yes, our open host circuit. The symbol is no, as you can see on the right, meaning normally open. It is named like this with an open contact symbol, and we call the circuit symbol. Have shown that the circuit symbol of our closed contact is also closed like this. We symbolize the circuit as a contact, yes. The internal structure of our relay is like this. Let's examine the working principles of its internal structure together on a simulation. Yes, first of all, we need to remove the coil and contacts of our relay. Let's place it. This is the coil of our relay. Friends, this is the common terminal. Our COM terminal, our closed contact and our open contact are connected to the inside of the relay in this way. we have placed the materials. Yes, in the coil of our relay. To provide the necessary power supply to our 24-volt DC power supply, we need. I placed it like this, and the coil of the relay. We can use a start button to control the energy that will go. If necessary to make connections later, I connected the DC power supplies plus N to the start button, guys. I also connect the start button to the A1 leg of the coil. I also provide the connection from the A2 leg of the coil to the end of my power supply. Friends. Yes, this is to provide the necessary power to my relay coil and to the control circuit I drew to control later. We need a 220-volt AC power supply to give the required voltage to the load we want. We need a power source, friends. A power supply with phase and neutral. Our source. Then we can also control the load like this. Let's place it here. We selected the load as the lamp. This is the control of the lamp together with relay. Yes, we will provide the COM terminal from the phase of our power supply. We are making the connection. Friends, the phase that will go to my load in this way. We connect the cable to the COM. That is, the common end. Then I make the connection from the contact output to my load. And from my load to neutral I have established the connection. Friends. In this way, we have completed the circuit. Right now, if we need to take a look at the circuit, I will show the connection from my phase terminal to my common terminal. I did it and my open contact is now in the open position here. There is no energy transfer, so my load is currently de-energized. Yes, here is the process that will take place before starting the simulation. Let's take a look. When I trigger the start button, my coil, the required energy will come and my coil will create a magnetic field as it is energized. This magnetic field will also provide physical movement to the COM end, creating a connection with the no open contact. In this case, my open contact will become closed. My closed contact will become open. And since the circuit will be completed through my open contact, my load will be energized. If you want, let's observe it together through the simulation. When I trigger the start button, my coil will be energized with 24-volt DCT. Then the magnetic field in the coil will pull the contact towards itself in this way. And my open contact will become closed. As a result, my load will be energized and the lamp will light up. My closed contact also became open. As you can see, the basic logic is, when the coil is energized, the closed contact becomes open. The open contact becomes closed. And in this way, I have provided the control process, friends. Now, if you want, how the circuit is symbolized in an electrical circuit drawing, and let's examine it together. Yes. This period equivalent in electrical circuit drawing and control drawing. We brought it here like this. Now, let's start matching the materials. Let's look together. First, we had a start button, electrical circuit. The symbol start button is like this, because it is an open contact. Button new. We symbolize it in this way. Yes, later on our relay, there was a coil. As we have shown before, this is A1 and A2. We symbolize it like this, with legs, and we have open contact. Common tip and open. We symbolize our contact together in the circuit drawing. This is clearly symbolized in the circuit drawing. Then we have the load connected in series to the open contact. This is the product we want to control. We also switch on our load. We show it this way with the symbol Yes, if you want this. We can also simulate the drawing of the electrical diagram by ourselves just now. You will also have the chance to watch the simulation we made in the electrical circuit. For example, when we press the start button, the coil of the relay will be energized and the open contact will be closed. Since it will become like this, our lamp, which is our burden, will also light up like this, my friends. Yes, we have shown the electrical circuit drawing in this way in this lesson here. We are done. See you in the next lesson.